Howdy. SciTech Daily. Volcanic Lightning, the science behind this spectacular phenomena. And October 9th, so it's 2 days old already. That's a picture from Chile. Really amazing. Check this out. This is lightning around the ash cloud. But let's have a read quickly. You've undoubtedly gazed out of the window to marvel a lightning storm in all its glory. Thunderstorms are certainly a sight to behold, but another much less common form of lightning is even more spectacular. As the name suggests, volcanic lightning is a lightning storm that occurs during a volcanic eruption. The science behind why it happens is more complicated than a regular lightning storm. Anyone remembering having tens of thousands of lightning strikes before the Tonga eruption, as well as during the eruption? What is the volcanic lightning? Volcanic lightning occurs in the plume of a volcanic eruption. Let me scroll up quickly. In the plume, or maybe it's outside the plume, but anyway, let's continue reading. Like all thunderstorms, volcanic lightning happens when static electricity builds up in the atmosphere before being released in the form of a lightning bolt. However, the static buildup isn't as straightforward as a typical thunderstorm. While the complete mechanism is not yet fully understood, research shows certain phenomena contribute to the charging. Lightning coming from above. I made at least one video. I have to search it. I'll try to put a link below when I find it once, where I somehow tried to explain that I think that this kind of static ash plume from a volcano is like an antenna to gather electricity from upper atmospheres. And this picture is really cool. The ash plume seems to gather energy from the upper atmosphere. But anyway, it must just look like that. Ice charging. Ice charging is the primary mechanism by which regular thunderstorms form, and it also plays a role in volcanic lightning, particularly those where the plume rises high into the air. As the warm air from the eruption rises into the sky, it meets colder air in the atmosphere. The water in the plume freezes into ice particles that collide with one another, knocking electrons from the crystals. These positively charged ice ions continue to rise and congregate higher in the atmosphere. Frictional charging. Frictional charging, also known as triboelectric charging. This is also thought to be a crucial mechanism leading to volcanic lightning, in the same way that ice charging occurs due to the ice particles colliding. Rock fragments and ash collide and create charged ions. The conventional currents that cause the plume to rise then separate this charge into different regions. Fractal emissions. I haven't read that yet. Similar to the frictional charging is fractal emissions, which is the breakup of rock particles within the plume. When the rock breaks, it is possible for charged particles to form, forming a buildup of static charge. This effect predominantly occurs at high energy. resulting in the charged congregation closer to the volcano's vent. So, let's recapitulate. First, it's ice in the hot ash plume. And now we have breaking rocks and it happens basically where it's high energy. So I assume it might be hot. Radioactive charging. Natural radioisotopes with the rock may influence charge buildup. Studies have shown that ash particles have natural radioactivity above the usual level. So think about that next time if there's a volcano going up there. Usually no one is measuring radioactivity. But anyway, let's continue. And charged areas can form when they decay. The extent radioactive charging has on volcanic lightning is unknown, although it might be a significant contributor in some instances. So are they trying to tell that since they think that Earth's core is this molten metal or radioactive, like everything is coming from within, the highest energy is coming from within, and the highest energy they know is radioactive? I don't know. This is a little bit confusing. Plume height, while not a mechanism in its own right, plume height can significantly impact whether lightning occurs. When an eruption results in a tall ash plume greater than 7 kilometers, there is a higher water vapor concentration. With more water present in and colder ambient temperature at this height, there is likely more ice charging and more electrical activity. For smaller plumes, that suggestion is that most of the electric buildup comes from fractal emission near the event, reducing the chances of a strike. While the science behind volcanic lightning is not complete, many factors are known to play a role. More research should hopefully provide a better understanding of what is happening during a strike. Yet, whatever the mechanism, there is no doubt it's a spectacular occurrence. It is spectacular indeed. These are pictures from Fuego volcano some weeks ago. These are all enhanced now, just in order to bring forth a little bit more plasma. Beside the vent, this is lava. This is plasma. Yeah. That's, I think, quite a sequence. Yeah, you cannot zoom in. And here you can see the first ones which are shooting off. Yeah, once if I have time, I probably make a better sequence for that because it's really disturbing that I zoom in here. I didn't think about the possibility that I have to make this kind of slideshow like that. I'm not a nerd. All done with the phone. Everything, all those links and stuff I put to my videos, they are free for everyone. This is the beginning. There's just this area here. Maybe it's actually bigger. And then it's developing this small plasmoid. And this is the unenhanced version. And this is now strongly enhanced as it continues to develop. Actually, wait a second. This is the unenhanced version of it. Yeah, this might not be the same. That's another one. I didn't do any enhancements to this. That's a straight screenshot. Now we go backwards, now forwards. And here is this ring, and as this breaks, there's one shooting off. The energy gets released like a soap bubble. If you blow up a soap bubble, as it explodes, you probably have noticed that the small droplets, they accelerate really quickly and they fly in all directions. They do not just drop down. They fly into all directions. That's why you got a wet face. Gravity. If the soap bubble, if there would be only the only force like gravity, if a soap bubble collapses, it collapses on Earth, usually because the water is like pouring down and there's a drop on the bottom of the soap bubble. This is what gravity does. It drains it. But as it explodes, or collapse, or how to put it, when the layer of the bubble breaks, and it is somehow the perfect example of minimal first distinction. You blow into this round thing with the water and the soap. You blow into that, and you make a bubble. Within the bubble, there's more pressure than on the outside. There's a different chemical. What is it? Anyway, different chemicals within that. And there's the bubble itself, like the sphere, the soap, water, which is the boundary. And as it breaks, the energy, what you were putting into that, gets released and it will dissipate in the energy of the environment. So it's really interesting to think about that, because it's really scalable. Like if the charge potential between the bubble and the environment doesn't, like, if, how to put it, if it explodes, the energy will go into all directions. And it's scalable. If you scale it up, like we know bubbles, like Earth has bubbles, many of bubbles, atmospheric bubbles, magnetospheric bubbles. We are in the bubble of the sun. We are within the sun's sphere. It's a big bubble. It's all spheres within spheres within spheres. So if one layer of one sphere breaks somewhere, it will have a huge effect. That's why I think ash plumes, continuous ash plumes, or whatever emissions from a volcano which reach certain heights, they are gathering the energy from this layer they're in. They're like antennas. If there's energy, it will find the volcano. And also this electric charge accumulation onto edges and points, how to say, peaks in this case. A volcano peak. Like St. Elmo's fire. Plasma. Ball lightning. Plasma rain, like on the sun. The Earth version in Guatemala. But anyway, I forgot where we started. Thanks, bye.